Welcome to this video. We're going to talk about how we can do the control unit lab. So we have our data path right here, and if you look in the library that I gave you, you will find this control circuit right here. And you can also double click on it and go into it. So I built most of this, or all of this, for you. And all you have to do is copy and paste this onto your data path. So to do that, just do Control A or Command A if you're on a Mac to select everything. Then you can copy and then go to your data path right here. And you might want to zoom out a little bit for this and then paste it in. And now we just need to drag it off to the side. And you want to be really careful. Grab something really big that you see, like this thing right here from our control unit, and then you can drag it over to the side right here. Now, if we were to zoom in on this right here, one thing that you might want to be careful of is there are some tunnels here that you might have used. Maybe you might have used a clear tunnel or a reset tunnel. So make sure that you don't have two switches conflicting with that. Now the one switch that might conflict is this reset thing right here. So if you already have a tunnel connected to a switch called reset and you put them in different position and you turn one on and the other off, then you'll have a conflict. So you might want to delete your reset from your data path and have this become a reset for your entire computer. So once you have that copied and pasted onto your data path, the next step will be to create your start button or your data button. You only need to create one of these, but you just follow the state machine design lecture. Just follow that video, but use this as your state transition diagram. And the B here stands for button. So you can see in this state right here, and this is the state you probably want to label 0, 0, or the first state right here. You can see that this button, it has an exclamation mark right there. So while they're not pressing the button, we're just stuck in this state, waiting for the button to be pressed. Once they press the button, we'll move to this state and we'll stay there however long they hold it down. So if they hold it down like for an eternity, half a second or so, and for a computer that can do 9 billion instructions in a second, that is an eternity. So if they're holding down the button, you're just stuck in that state. As soon as you release the button, we'll go to this state right here and produce an output. So this will signal our machine to start, if this is our start button. And again, we make two copies of this, and then we have another copy for our data button. So when we want to acknowledge that we've seen an output or that we're ready to give in an input, and then this signal will tell the computer we're ready, but it will only do it for one clock cycle, and then it will move back here, waiting for them to press the button again. So follow the other video, the state machine design video, and make state machine your button state machine. And when you turn it in, you will need to have these pictures of these either in your video or send these pictures in. Just zip it up and send your video with pictures that show that you designed your own state machine. Now I just want to give you a clear idea that this is our sync button right here. And if you notice, it has 3 inputs. So what are the 3 inputs? One is the switches like start and data. The other one will be the clock. And the third one is a reset. And then you have the one output. And I just want to show you how you connect this button to your control unit. You see right here, so this was the start wire that's blue, and then we also had the data wire where the data connects. But you can see that my clear or the reset line is hooked up here. We have the clock coming in, so it's sharing the clock with this guy right here. And Then this is the button right here. And then you have another one. It's the same circuit placed down again with the clock and clear. And now this one is the data switch. And then the output connects to the data tunnel. So that's how you connect it up. And once you get it connected up, all you have to do to pass off is, of course, show your pictures for doing your state machine design. We need to see the state transition table, the K-maps with the final circuit, and then, of course, make sure you show your state machine that it's working the way that it's supposed to. Show that in your video. And then connect it to this, and then make a video of this thing going through the states 50, 51, 52, 53, and then jumping to 0, 0, 77, 78, 79, and then back to 50. And then, of course, you have your IR register up here that you can change around and try out different instructions. And again, watch for one more video that I will post that will talk about exactly how this works and what it does. So one more thing I want to show you just to make sure you understand how those inputs come together. This, if you're watching the state machine design video, at the end you put down 2D flip-flops from memory. You connect this triangle input together, both of them together, and that becomes your clock, the input that you want to be your clock. Now the clear is supposed to reset these to state 0, 0. And this is why I recommend that your first state or the start state start in 0, 0, because when you turn on clear, it'll reset it to state 0, 0. So to do that, see this R right here, that means to clear it out. And so you can connect that to the clear. And then finally, you have your button input right here that'll feed into the logic right here. And you'll have to come up with a circuit by doing your state machine design. And then the output will be an AND gate that will be encoded for that one signal output state so that it will turn on that one output. And once you get that, there are all of your inputs that you have for your button. Thanks for watching.